Any polynomial function is always continuous in closed interval. Polynomial functions are continuous in what? Closed interval. Slope is 0 because tangent is parallel to the x-axis. You know, if any line is parallel to x-axis, its slope is 0. Rolle's theorem is said to be satisfied if the function is continuous in closed interval, if the function is differentiable in open interval, and first we proved it is continuous in closed interval, then we proved it is differentiable in open interval, then we found out f of a and f of b. So in Rolle's theorem, f dash c we equate it to 0, but in mean value theorem, f dash c is f of b minus f of a divided by b minus a. Welcome to the session, dear students. In my last class, we have discussed successive derivatives. In today's class, we'll go ahead with mean value theorem and Rolle's theorem. So here, when you talk about graphical approach, actually geometrical meaning of dy by dx is slope of tangent to the curve. So if I have a curve like this, I can draw at one particular point in the interval, say a and b are the two intervals. So between these intervals, we'll have a C, point C, at which we can draw a parallel tangent to the x-axis. So slope will become 0. All those things we'll be studying in application of derivatives. So suppose if you have any graph, so between 2 points, 2 intervals, say we take 2 intervals a and b, there will be one point called C at which tangent, how is the tangent here? Tangent is parallel to what axis? Tangent is parallel to x-axis. If tangent is parallel to x-axis, slope is 0. Geometrical meaning of dy by dx is slope of tangent. So that will be 0 because slope is 0 because tangent is parallel to the x-axis. You know, if any line is parallel to x-axis, its slope is 0. That is a basic with which the topic starts. But here, we don't draw the graph, we don't draw the tangent, but we use the theorems. The very first theorem is Rolle's theorem. So Rolle's theorem says that a real valued function, say y is equal to f of x, we say set to satisfy Rolle's theorem. A function is said to satisfy Rolle's theorem if it satisfies 3 conditions. Condition number 1, so the function should be continuous in closed interval. The function should be continuous in closed interval AB, and the function should be differentiable in open interval AB, and f of a value should be equal to f of b, upper limit and lower limit. So a functional value at a and functional value at b should be same. And once these 3 conditions are satisfied, then find f dash x, then find f dash c. So then find f dash c, equate f dash c to 0 such that we'll get a c, and that c should be in the interval. So when can you say a function satisfies Rolle's theorem? We say a function satisfies Rolle's theorem if f should be, the given function should be continuous in closed interval AB. In the given interval it should be continuous, and the function should be differentiable in the open interval. And f of a should be equal to f of b. Functional value at a and functional value at b should be equal. And when you do f dash c equal to 0, when you equate f dash c to 0, you should get a c, and that c should lie between a and b. That c should be in the interval, open interval AB. See, compulsory for 3 marks. If you see the past board papers, many questions has been appeared on Rolle's theorem and mean value theorem for 3 marks. They'll ask you to verify Rolle's theorem. When they ask you to verify Rolle's theorem, first thing you should see whether the function is continuous in closed interval. You should see whether the function is what? Continuous in closed interval. Means the graph should be continuous. The function should be continuous in closed interval. It should be differentiable in open interval. Open interval. And f dash c, f of a and f of b should be equal. F of a value should be exactly equal to f of b. Then find f dash x, then find f dash c, and f dash c value, when you equate it to 0, you should get a c, and that c should be in the interval. If you don't get a c in the interval, then theorem is not satisfied. Rolle's theorem is said to be satisfied if the function is continuous in closed interval, if the function is differentiable in open interval, and f of a value should be equal to f of b, and there should exist f dash c such that when you equate f dash c to 0, you should get c value within the open interval AB. So now, to make you understand better, we'll start with the problems. The problem, This is an important problem that appeared in the past board paper. Verify Rolle's theorem for the function f of x is equal to x square plus 2 and x belongs to the interval minus 2 to 2. So now we'll start the solution. Here they gave the interval. So what is given? Function is given. What is the function given? So we'll take the given function and given interval. F of x they give. What is f of x? F of x is x square plus 2. Please understand, x square plus 2 is a polynomial function of degree 2. Any polynomial function is always continuous in closed interval. Polynomial functions are continuous in what? Closed interval. They gave f of x is x square plus 2. We say is continuous in closed interval. Not only this, any polynomial function is continuous in closed interval minus 2 to 2. Why I can say it is continuous? Because it is a polynomial function. So all polynomial functions are continuous. How to prove continuous? You know how to prove. Limit extends to c, f of x should give you f of c. But here you no need to prove. Observe, if it is a polynomial function, you can say it is continuous in closed interval. And f of x, so how to describe this or how to write this is, so solution starts like this. We call the lower interval as a and upper interval as b, and f of x is equal to whatever they give. What is given? X square plus 2. Just now I told it is continuous. And why it is continuous? It's a polynomial. F of x is equal to x square plus 2 is polynomial function, and all the polynomial functions are what? Continuous. Polynomial function. So because it is polynomial function, you know polynomial functions are what? Continuous. F of x is x square plus 2 is polynomial function. Therefore, it is continuous. Because it is polynomial function, I can say it is continuous. And second thing is, f of x is again x square plus 2 and continuous in what? Closed interval minus 2 to 2. Please understand, function should be continuous in closed interval, then Rolle's theorem we can further proceed. Because it is polynomial functions, all the polynomial functions are continuous in all the, for all the real numbers it is continuous, and minus 2 to 2 we will get all real numbers, so it is continuous. Then f of x is equal to x square plus 2 is differentiable. It is also differentiable. Differentiation exists in real numbers. So they give open interval you should take. Differentiability should satisfy in open interval. Continuity should satisfy in closed interval. We have to write. Writing these two, you will get 1 mark. So now, because it is polynomial functions, remember all the polynomial functions are continuous in between real numbers, and they are also continuous, and also they are differentiable in the for the real numbers. Here the interval is real number, so these two. Writing these two, 1 mark. And you should find f of a. Find f of a. F of a means here a is minus 2. Find f of minus 2. What is f of minus 2? In the place of x put minus 2. So it gives you minus 2 the whole square plus 2. Minus 2 the whole square is 4. 4 plus 2 is 6. So you got f of a value. What is f of a value? 6. So f of a is exactly how much? 6. We got it. Now find f of b. Now we need to find what? F of b. So we'll go to f of b. F of b means f of upper limit. What is upper limit? F of 2. What is f of 2? That is 2 square plus 2. That is 4 plus 2, 6. So f of b is also 6. Now, therefore, f of a value and f of b value are same. So according to Rolle's theorem, 3 conditions has to satisfy. All 3 are satisfied. First condition is what? It should be continuous in closed interval. It is continuous in closed interval because it is polynomial function. And it should be differentiable in open interval. It is differentiable again because it is polynomial function. Then third thing is f of a should be equal to f of b. Here f of minus 2 value and f of 2 value both gives you 6. F of a is also 6. F of b is also 6. Therefore f of a equal to f of b. All 3 conditions are satisfied. Now you should find f dash x. So they gave f of x. What is f of x? X square plus 2. So now differentiate both sides with respect to x. Differentiate both sides with respect to what? X. If you do that, you will get d by dx of f of x is equal to RHS. D by dx of x square plus d by dx of what? 2. D by dx of f of x is f dash x. And d by dx of x square is 2x. And derivative of 2 is what? 0. So you got f dash x. What is f dash x? You got 2x. So you got f dash x 2x. and now you find f dash c. What is f dash x? 2x. Similarly, what is f dash c? F dash c means in the place of x put c, so 2c. F dash x is 2x, f dash c is 2c. Now we need to equate f dash c to 0. Equate f dash c to 0 and get the value. So further, f dash c equated to 0. What is f dash c? 2c. 2c is 0. What is c? 0 divided by 2. That implies c is what? Exactly 0. You got c. And that c is equal to 0 belongs to minus 2 to 2 open interval. Do you agree or not? C value is 0. 0 is a number between minus 2 and 2. It should lie in open interval. So 0 is a number between minus 2 and 2. So therefore, what is the conclusion? Therefore, Rolle's theorem is verified. Rolle's theorem is verified. Is what? Verified. Now all of you understood this. Let me just summarize this. So first what you should do? You should prove continuous in closed interval minus 2 to 2. Then what you should prove? You should prove it is differentiable open interval minus 2 to 2. Then you should find f of a. In this problem we got f of a exactly as 6. Then you should find f of b. We got f of b exactly as what? 6. So therefore f of a and f of b should be equal. We got that also. Then you should take f of x and differentiate both sides. When you differentiate both sides, derivative of x gives you f dash x, and derivative of x square is d by dx of x power n is n into x power n minus 1. So it will give you 2x. Derivative of 2 is 0. So f dash x you got, that is 2x. And if you want f dash c, replace x with c. F dash x is what? 2x. F dash c means in the place of x put c. So you got f dash c. You got f dash c also. After you get f dash c in Rolle's theorem, equate f dash c to what? 0. So I equated f dash c to 0 from here. So when you equate f dash c to 0, so what is f dash c, my dear students? 2c. So in the place of f dash c, put 2c. So f dash c is 0 means 2c is 0, and transfer 2 to that side. C is 0 by 2. 0 by anything is 0. C is equal to 0, and c is in the interval. And the c value, whatever you get, should be in the open interval. What they give? So open interval minus 2 to 2. So c belongs to this. So therefore, conclusion is what? Rolle's theorem is verified. I hope all of you understood this. They give polynomial functions. Remember, polynomial functions are always continuous. What are the steps in Rolle's theorem? First, you should prove it is continuous in closed interval. Second, you should prove it is differentiable in open interval. Third, you should prove f of a value is the same as f of b value. Fourth, you should find f dash x and then f dash c. And fifth, you equate f dash c to give 0 and get a c value, and the c value should lie in the open interval. In this problem, we got c 0. It lies between minus 2 and 2. Next, examine Rolle's theorem applicable to this function or not. Now observe, f of x is given. My dear students, again f of x is what? Polynomial function. Polynomial functions are always continuous for any real number. It's polynomial function of degree 2. So therefore, we'll write the same. F of x is what? Is a polynomial function. Is a polynomial function. Therefore it is continuous in closed interval. It is continuous in what? Closed interval minus 4 to 2. And again, f of x is a polynomial, so it is also what? F of x is differentiable. F of x is what? Differentiable in open interval between the real numbers, that is minus 4 to 2. It is differentiable also. And then find what? F of a means lower limit. So what is the lower limit? Minus 4. So find f of minus 4. F of minus 4 means in the function, in the place of x, put minus 4. So it will become minus 4 the whole square plus 2 into minus 4 minus 8. That is minus 4, when you square it, it will become plus 4 square is 16, plus into minus minus 8 minus 8. So 16 minus 8 is 0. So you got f of minus 4 is equal to what? 0. Or f of minus 4 you got 0. Or we say that is f of a is 0. F of a, how much you got? 0. Now we go for f of b. Find out f of b. f of b means f of upper limit. What is the upper limit? 2. So find f of 2. What is f of 2? In the place of x put 2. If you put 2, you will get 2 square plus 2 into 2 minus 8. 2 square is what? 4. 4 plus 4, 8 minus 8, 0. So you will get f of b also as 0. So what is the conclusion? Therefore you can conclude f of a value is same as what? F of b. So by this we followed all the three conditions. First we proved it is continuous in closed interval, then we proved it is differentiable in open interval, then we found out f of a and f of b, again they are equal. Now you go to f dash x. So what is f of x they give? F of x in the problem they give x square plus 2x minus 8. F of x is what? X square plus 2x minus 8. Now differentiate both sides with respect to x. So differentiate both the sides with respect to what? X. When you differentiate both sides with respect to x, LHS is d by dx of f of x, RHS is d by dx of x square plus d by dx of 2x minus d by dx of 8. So d by dx of f of x is f dash x, d by dx of x square is 2x, 2 is constant, take it out, derivative of x is 1 minus derivative of 8 is 0. So now we got f dash x. What is f dash x value? F dash x value is 2x plus 2. And find f dash c. What is meant by f dash c? In the place of x put c. So it will become 2c plus 2. Now equate. So we got f dash c. What is f dash c? F dash c is 2c plus 2. So equate f dash c to 0. That is 2c plus 2 equal to 0. That implies 2c is equal to minus 2, or c is equal to minus 2 by 2. C is minus 1. So you got the value of c. What is the value of c you got? C you got minus 1. And that minus 1 belongs to open interval. You know, minus 1 is a number between minus 4 and 2. So belongs to open interval minus 4 to 2. It should lie between. So C is minus 1. Yes, in number line if you see minus 4 and minus 2, between that we'll have minus 1 also. So it is in the interval. Therefore, what is the conclusion? Rolle's theorem is verified. I hope all of you understood this. So what is the first thing? First you should prove continuous. It is polynomial, therefore it is continuous. Then you should prove differentiable. It is polynomial, therefore it is differentiable in open interval. Continuity should be in closed interval. Differentiability should be in open interval. Then find f of a, that gives you 0. Then you find f of b, that also gives you 0. So f of a should be equal to f of b. We got that. Then find differentiate both sides. You'll get f dash x. F dash x you'll get 2x plus 2, f dash c will get 2c plus 2, then equate f dash c to 0, you'll get c value, and c value will get what? Minus 1. After you get c minus 1, check whether it is in the interval. Yes, c is minus 1, it is in the open interval minus 4 to 2, therefore Rolle's theorem is verified. I hope all of you understood this. This is simple problems I have taken. Though they are simple problems, these are the problems that appeared in the past board papers. Then we'll go to the level 2 problems also. Before that, we'll also see what is mean value theorem. So now I hope all of you are thorough with the Rolle's theorem. Now we'll go to what? Mean value theorem. So just before we step into mean value theorem, what is the first step in Rolle's theorem? In Rolle's theorem, the first step is we should prove it is continuous in closed interval. In mean value theorem also, function should be continuous in closed interval, same. And there we should prove it is differentiable in open interval. Here also we should prove it is differentiable in open interval. There we should find f dash c. Here also we should find f dash c. But here f of a need not be equal to f of b. Here f of a and f of b, we are not checking whether they are equal or not. That is the difference. First you should prove continuous in closed interval, then you should prove differentiable in open interval, then you should find f dash c, and f dash c should equate it to f of b minus f of a by b minus a. This is the difference. There f dash c in Rolle's theorem is f dash c equal to 0, we solved. But here what is f dash c formula? F of b minus f of a by b minus a. What is f dash c formula? F of b minus f of a by b minus a. This is f dash c formula. Then equating it, solve and get c, and that c should lie in open interval. That c should lie in what? Open interval. This is the rule. Now, so mean value theorem means what? First prove what? Continuity in closed interval. Then differentiability in open interval. Then directly find f dash c, f dash x, then equate f dash c, and this is the only difference. So in Rolle's theorem, f dash c we equate it to 0. But in mean value theorem, f dash c is f of b minus f of a divided by b minus a. What is the formula? F dash c is f of b minus f of a by b minus a. So if you equate this, you will get c, and that c again should belong to open interval. Please recollect this formula. What is the formula? F dash c is f of b minus f of a by b minus a for mean value theorem. For Rolle's theorem, this part will become 0. F dash c is 0. But here we are using mean value theorem, and I'll solve some problems on this. Verify mean value theorem if f of x is x cube minus 5x square minus 3x in interval 1, 3. This is one question. And we have another question, that is verify mean value theorem x square minus 4x minus 3 in the interval a is equal to 1 and b is equal to 4. Two problems are there. First we'll start with simple problem and we'll go ahead with, so both the problems are equally important. This is degree 3. Degree 3, when you differentiate, it will become degree 2. Degree 2 will give you 2 roots. In that we have to pick the root, or we have to get at least one root in the interval. So we'll see that. So they are asking to verify what? Mean value theorem. And f of x is what? X cube minus 5x square minus 3x. What is the conclusion? It is what function? It is a trigonometric function? Is it a logarithm function? Is it exponential function? Is it a polynomial function? It is polynomial function of degree what? 3. So they have polynomial function. So first you should decide what is the nature. It's not trigonometric, it is not logarithmic, it is not exponential, it is simple. It is what? Polynomial function. All polynomial functions, what I taught you, all polynomial functions are continuous in what? Closed interval. So first step, what we'll write? First we'll write f of x is equal to given function. What is the given function? X cube minus 5x square minus 3x is what? Polynomial. Is what function? Polynomial function. So therefore what is the conclusion? So you should say therefore f of x is continuous in closed interval. Continuous in closed interval, that is 1 to 3. They give an interval, and f of x is also differentiable between the intervals, we should see. That's why in open interval. That is open interval. What is the interval they give? They give an interval how much? 1, 3. So these two you should write. Then f of lower limit. What is lower limit? 1. F of a means f of 1. What is f of 1? In the place of function put 1. If you put 1, it will become 1 cube minus 5 into 1 square minus 3 into 1. That is 1 minus 5 minus 3. 1 minus 5 minus 3, that will give you minus 7. And further find f of b. F of b means upper limit. What is upper limit? F of 3. Find f of 3, that will be 3 cube minus 5 into 3 square minus 3 into 3. That is 5 cube is 27, 3 cube is 27, minus 3 square is 9, 9 5 is 45, minus 9. So 3 cube 27, 9 5 is 45, minus 9. 27 minus 9 gives you 18, 18 minus 45. Now we got the value, minus 27. Then f dash x. So find f of x is given, find f dash x. What is meant by f dash x? Directly derivative of this. What is derivative of x cube? 3x square. What is derivative of this? 10x minus derivative of 3x is 3. So apply d by dx on both sides. D by dx of f of x is f dash x. D by dx of x cube is 3x square. Minus is there, put minus. D by dx of 5 into x square is 5 into 2x, that is 10x. Minus is there, put outside, and derivative of 3x is what? 3. Now we got this. Now f dash c. F dash c means in the place of x put c. It will become 3 square minus 10c minus 3. Now we have to use mean value theorem formula. What is the formula? F dash c is equal to f of b minus f of a by b minus a. So use the formula f dash c is equal to f of b minus f of a by b minus a. So what is f dash c we got? 3c square minus 10c minus 3 is equal to f of b. What is f of b? Minus 27 minus of f of a. F of a is what? Minus 7 divided by b minus a. B minus a means upper limit minus lower limit. That is 3 minus 1. Simplify this further. So that is 3c square minus 10c minus 3 is equal to, minus of minus becomes plus 10 divided by 2. So 2 ones are 2 tens are. So 3c square minus 10c minus 3. Bring this side, so it will become plus 10 is equal to 0. So 3c square minus 10c plus 7 is equal to what? 0. Now we have to do middle term factorization and get two values for c. I hope all of you understood till this. Now let me erase the first part because it is simple. What is the first part? We proved continuity and differentiability. Okay, now f dash c we have done. So solve this. 3c square minus, so what are the factors for 7 into 3 if you do? 21. What are the factors for 21? That gives you minus 10, minus 7, minus 3 I can take. If I multiply, I'll get plus 21. If I add, I'll get minus 10. See, do middle term factorization. So I can write minus 3c minus 7c and minus 3c minus 7c plus 7 equal to 0. Now in these two, take 3c common, it will become c minus 1. In this take minus 7 common, it will become c minus 1. Again take c minus 1 common, so it will become 3c minus 7 equal to 0. Each term c minus 1 equated to 0, you'll get c is equal to 1. And 3c minus 7 equated to 0, c becomes 7 by 3. See, please understand, select, at least you should get one value of c which belongs to the open interval. So now one value of c is what? 1. The other value of c is what? 7 by 3. So in the interval 1, 3. So c is equal to 1 does not belong to open interval. Open interval means what? In between. It is not in between. 1 is the border. So we cannot. But same c is equal to 7 by 3. All of you know 7 by 3 if you divide. So 2 point something lies in what? Interval. 2 point something. So now you can divide using calculator. 7 by 3 if you divide. So really if you divide 7 by 3, 3 2s are 6. So 10. 2.333 lies between 1 and 3. Do you agree or not? So at least one value got. This is not there, but this holds good. So therefore mean value theorem is satisfied. What is satisfied? Mean value theorem is satisfied. So my dear students, very important note is in Rolle's theorem, f of a and f of b should be equal. But here, f of a and f of b are different. F of a you got minus 7, f of b we got minus 27. They are different. And in Rolle's theorem, we equate f dash c to 0. But in mean value theorem, f dash c is equal to what? F of b minus f of a by b minus a. And solve this, we will get a quadratic equation. You know, quadratic equation will have two roots. So we'll get two values for c. One is 1 which is not in the open interval. The other one you will get 7 by 3. 7 by 3 lies between the two numbers 1 and 3. So I can take, so mean value theorem is satisfied. If you don't get any value between 1 and 3, then it is not satisfied. But now you got 7 by 3. It lies in the open interval, so it is satisfied. Next we have one more problem. F of x they give. It's polynomial. It is continuous in closed interval. It is polynomial, it is continuous in open interval, and a value is 1, b value is 2, and it's a degree 2. If you differentiate, it will become degree 1, you can solve it. So now f of x is what? First step you should write, it is continuous in what? It is continuous in closed interval. What is a closed interval? They give 1 to 4, 1 comma 4. Again, it is f of x is what? Differentiable. In what? Differentiable in open interval. It is must to mention this. If you forget, you lose 1 mark. Then you should find f of lower limit. F of what? 1. F of 1 means what? 1 square minus 4 into 1 minus 3. That is 1 minus 4 minus 3. 1 minus 4 is minus 3, minus 3 minus 3 is minus 6. And then you should find f of, we call this as what? F of a. F of a. Then you find f of b. F of b means what? F of upper limit. That is f of 4. That is 4 square minus 4 into 4 minus 3. So 4 square is 16. 16 minus 16, 0. So it will be minus 3. Here you can see f of a and f of b are not equal. And in Rolle's theorem, it should be equal. In mean value theorem, they are not equal. And you got f of a. What is f of a? Minus 6. You got f of b. What is f of b? minus 3. Now you go for what? F dash x. What is f dash x? Derivative of f of x. So differentiate both sides. F of x becomes f dash x. This will become 2x. This will become minus 4. Now find f dash c. What is f dash c? In the place of x put c. And what is mean value theorem? F dash c is equal to f of b minus f of a by b minus a. So f dash c is what? 2c minus 4. So 2c minus 4 is f of b. What is f of b? Minus 3 minus of minus 6 becomes plus 6 divided by b minus a, that is 4 minus 1. Further simplify, LHS is 2c minus 4 and RHS becomes 3 by 2, that is 2c minus 4 is equal to, this will become 3 by 2, or 6 minus 3 is 3, 2 by 3, 3 by 3. So 4 minus 1 is what? 3. So it will become 1. So 2c is equal to what? 1 plus 4. C is equal to what? 5 by 2. All of you know 5 by 2 is what? 2.5. 2.5 lies in the interval 1 to 4. So you got C belongs to what? Open interval 1 to 5. Therefore 1 to 4 whatever they give. So they give 1 to 4, right? So 1 to 4. So therefore what is the conclusion? Therefore mean value theorem is satisfied. That's it. Satisfied. MBT is satisfied. I hope all of you understood what I taught you people. So we have done Rolle's theorem and mean value theorem. In today's class I have done all the standard questions required for board exam for 3 marks, for PU board exams. But are they sufficient? So to gain knowledge and you have to get skills, so you practice more and more problems. So as many problems, we have trigonometric functions, we have logarithmic, exponential, there we have to check Rolle's theorem and mean value theorem also. So now I expect you to solve more questions and become thorough. Thanks for attending the session. I'll see you in my next session. Thank you.